Hello. Hi guys, good morning. Welcome back to a new video. And people just keep on saying, Aryan, that in night you always say good morning. Bro, it's 12:20. It is AM, 12:20 AM. So hi guys, good morning. Welcome back to a new video. Again, we are seeing question number 3 of today's bi-weekly contest, as in yesterday's bi-weekly contest, which is just 3 hours ago or 4 hours ago. And it was 126 contest. The problem 4 we have already live, so problem 4 you can just go and check out anywhere in iCard or maybe in description or maybe somewhere, or you can just search for the problem name. You can just simply find it. In this we will see 381, replace question marks in strings to minimize its value. It is one of the questions in which I might end up telling you something right now. Again, I'll for sure say, firstly, go try this question. This is one question I'll ask by myself. I'll ask you. Please go and try, because there is one thing, there is nothing called as intuition in this question. Intuition, what is there, I'll tell you, but there is some edge case which you might end up thinking only and only when you will try it by yourself. Although I'll tell you, but that would not be that intuitional for you to figure out the edge case itself. Because edge case is edge case. Now, it simply says that you are given a string S. Now, S of I is either a lowercase English letter or a question mark. Either a lowercase English letter or a question mark. So, S of I is alphabets A to Z or a question mark. Now, for example, they have given a reference of a new string. Again, this string T is never used. They have just given a reference. Imagine that you have a string T of length M, which consists of lowercase English letters. Now, we define the cost at the index I. Again, that's a very important part. Please listen very carefully. The cost at the index, again, remember, we have a string T in which we have different characters at these indexes. Usually, you have seen that if you had been watching, I always represent the array or the string by saying, okay, string name and then some empty underscores, which means, okay, these are the places or the indexes at which some values can come in. Either it can be, if it's an array, the values can come in. If it's a string, the characters can come in. Now, so the cost at the index I, which means at that specific index I, the cost at that index will be nothing but the number of characters equal to that T of I. Again, the element will be T of I. So the cost of I, the cost at the ith location will be number of characters which is equal to T of I. So if let's say the character, again, we have characters. So let's say here it was A. So if I have A here and B here, then the cost at ith index will be nothing but 1, because I have 1 A's, right? What if I had 2 A's, then the cost would have been 2. What if I had no A's, then the cost would have been 0 at that ith index. Okay, now that appeared before it, before that index only, make sure before that index, and that too we have to go and find out in this, when they say before, they for sure mean from starting index 0 to index I minus 1. Now they gave you the reference, or basically they gave you the evaluation of the cost of I, but the next time they are saying is the value of a T. Now I just told you the value. I just told you the cost, how the cost is defined. But the value of a string T, it is defined as the summation of cost of I for all the indexes. The summation of cost of I, where I is from index 0 to index n minus 1. N minus 1. This is actually your value of your string T, right? For example, for the specific string T, they have given, okay, T is nothing but A, B. The cost at this index 0 will be nothing but number of A's behind it. We have no A's, so the cost here is a 0. Okay, at index 1, number of A's behind it. Oh, I have 1 A, so for this the cost is 1. At index 2, number of B's behind it. Behind it I have no B's at all, so the cost is 0. So that's how you can simply see my cost in total, or value in total for the string T came out to be as 0 plus 1 plus 0, which is nothing but 1 itself as the final answer. Now you have figured out what does the cost mean and what does the value mean. Okay, this entire portion was a reference which they had given with the help of a string T. Coming on back to a main question. Main question simply says that your task is to replace all the occurrences of question mark, because you remember in the very beginning They told you that in a string S, you have lowercase English letters and the question mark. So you have to now replace the question mark. Again, replace all the occurrence of the question mark with any lowercase English letters. But okay, I can replace everything with A. Who cares? No, bro. With the condition that the value of a string S, again, let's imagine that this would have been a question mark. So you have to replace it with some other character. If you have replaced this with, let's say, C. So at this index, no character is like C. So the score would have been 0. The cost would have been 0. And the addition of all the costs is nothing but the value of the string. So the value came out to be a 0. And this is the value which you have to minimize. You have to get the minimum value possible. And again, let's say you can get 2 such strings giving you the minimum value. You can get 2 such strings giving you the minimum value. So we have to return the string which is lexicographically smallest. Aryan, how is it possible that 2 strings? Very simple example. Let's say you had 3 question marks. Let's say you imagine that you made the string as ACB. But I'll say, bro, you have to give the lexicographically smallest string. So you will give a ABC. And that's the answer. That's a lexicographically smallest string. Which again, both of them will give a value. Again, value remembered. Both of them will give the value of a string as a 0 itself. This also and this also. It's just that this is lexicographically smaller. So first priority is decreased value. Second priority is, okay, when the value is same, then second priority is it should be lexicographically smallest string possible, and that's what I have to return. Now we will go on step by step and everything will derive from the question itself what we have to do, right? If again, let's take a few examples. That will be very simple. We have question mark, question mark, question mark. Again, we will just try to derive by ourselves. Okay, question mark. What should I place? But remember the main task. Main task is this specific thing. This entire thing is the main task. Remember how the score is being generated. Many things can confuse you. Aryan, so what happened is when I'm at the index I am taking and grabbing the number of A's previously to me. So shall I store a prefix, some kind of a concept that, okay, so far how many A's have been there? Shall I store that part? Maybe, maybe not. Again, that's a question. So you might end up, because it feels like that you are keeping track of the prefix values. Whatever the prefix value is, you keep track of that. You are keeping track of that, right? Is it required actually? Maybe, maybe not. Aryan, why are you saying maybe, maybe not? I can easily see it is required. Bro, if I ask you that what if this A would have been here versus this A is here, which means, okay, previously you saw this A was here. Imagine it coming on back that let's say we have a A here and then remaining are, let's say, C and D. Forget for now. Now I'm just trying to conflict A's and I'm trying to show you that how and what thing matters for us. We have to ultimately figure out what thing matters for us. So I can simply say, for this the cost is 0, for this the cost is 0, because for B there is no other B's, and that's the reason I just made a simple example that, okay, cost is 0, cost is 0. So only the cost of this specific A will actually be incurred, and that too only because of saying, okay, I have one A previously. So the cost of this A, again, the cost of this index will be 1. But now I ask you, what if this A would have been here and this D would have been here? Will that matter? Will that matter? No. Still, the cost at this index would have been 1. I'm not concerned about the cost at that index. I'm concerned about the value ultimately, and that value is the summation of all the costs. So it doesn't make sense for me. Like, it may or may not be that, okay, it's a luxury for me. I can place my characters anywhere. But please make sure that you stick this to your mind and stick that in the correct way. I am saying only if something is fixed in the string, that is fixed, which means if I have something as fixed, which means in this example, if I have A here, so in the final answer, A will be here. I can only replace the question mark. So make sure that thing. Now coming on back, That's a simple stuff which we might end up like just a hunch for us. Maybe we can use prefix sum, but then maybe thought we that okay, we might not require the prefix sum because we don't need that specific index itself. We need okay, that index can be anywhere else. It's just for me, how many such characters are there previously? For me, how many is a question. Remember that for fact. For me, how many is a main question. Location was never the question. How many was the main question. I can do this by the prefix sum also. I can do this by a simple map of frequency also. That's what I can do. But coming on back to the example, we had question mark. Very obvious, Aryan, very obvious that I need lexicographically, and then I need one thing that okay, my score should be minimum. So I saw one thing that my score as in my value is nothing but the summation of the cost, and cost is only incurred when I see something same as that of me, which means if I am at this specific index, if I see something same as that of me, so I will have to increase my cost. So I'll do one thing, I will keep everything as distinct. So I will say okay, put a A, put a B, put a C. And what I found out is that what I will end up doing is wherever the question mark, I will keep on placing distinct characters A, B, C like this. That's the best way. Great, let's try this. A question mark A. Keep on placing A, B, C. I'll place A here. Bro, that's a mistake you did. You placed again. You cannot touch these two. You had a liberty to place something here. But you thought of, okay, I will keep on placing A, B, C, D, and up till Z, and then again A, B, C, D up till Z, and that will be the best optimal solution. Greedy and best optimal one. Bro, you saw that it hampered you. How it hampered? Because you were placing a here. A was already placed previously. This will actually hamper you. Now comes the fact that A not only hampered your previous, it also hampered your next score. So because of placing A here, it increased your cost, or basically it increased your value by 1 because of this A. As soon as you placed A here, it will say okay, before me I have 1 A's, so it will increase the cost by 1. Okay, 1 cost increase. When you placed A here, for this the before is this. So because of placing a A here, the cost corresponding from here to here will actually increase by 1. Earlier the cost for this specific A was only 1 because of this A. But now as soon as I placed another A here, the cost for this A will increase to 2. So this A, it increased the cost of further ones also. So you saw, oh Aryan, I don't need only prefix sum. As in, I don't need only the prefix frequencies. I also need the suffix frequencies also. So there is no thing, okay, I can just name things, but there's no thing as I will keep track of the prefix frequency only, like prefix sum or prefix frequency only. Nah, I will have to also keep track of the suffix frequency, right? Because you saw that Aryan, what if here it would have been a C? Then if I would have placed a here, it would have impacted my prefix. If I would have placed a C here, it would have impacted my suffix. So I need the frequency of all the characters rather than saying I only need the prefix frequencies or the suffix frequencies. Okay. So very obviously that we know that we cannot place A, or we should not place A. By human eyes we can see we should not place A. Rather let's place something else. Oh, for sure. Next comes character is B. So far we have got 2 rules. I am just trying to place all the characters, which means A, B, C, D, E, F, G up till Z, and then again I'll just keep on recycling it. Okay, A, B, C up till Z. Then I figure out one thing else, that okay, if some character is not present, I should place that character itself. Okay. But now if I ask you, bro, if let's take the other example itself, that okay, examples are done. Okay, done, no worries. But so far we have just realized these 2 rules. So are we good to build the answer? Let's see what answer we will be able to build because of that. So making an imaginary string. Let's see, making an imaginary string. A question mark, B question mark, C, and again let's keep on going. D, and so on and so forth. Right, so on and so forth. we might end up increasing the size depending upon the answer. Now, first, as I land onto this specific index, because see, this I cannot change, this I cannot change, I can change only these ones. If I change only these ones, what's going to be the case here? I have to keep track of the frequencies of all the characters, because I know I will put that character here who has the least frequency, because we know that as long, again, Aryan, we can easily see that other characters like example E, F, G, H are not even there, so you can place those characters, right? Why, I don't know why it is not moving. So you can place those characters. I can say, yeah, I can place, but what if all of them are here? E, F, G up till let's say Z, all of them are here. Then what you will do? So you will keep track, bro. I know that it doesn't matter what's the location of the element. The only thing which matters is the frequency. So I'll keep track of the frequency of all the elements. Okay, frequency of A is 1, frequency of B is 1, frequency of C is 1, frequency of D is nothing but 2, and then E1, and then so on and so forth. Now, I have to place something here. I will grab out the minimum frequency element. It can happen that maybe H is not even here. So frequency of H would have been 0. So, which is not even there, frequency 0. I will grab out the minimum frequency element, which is not yet used. So, okay, I will actually place an H here. I will place an H here. Great, great, super great. Again, considering H was not there. H was not there for us. In the entire string S, my H was not there. So, I just simply grab this H and I place an H here. That seems awesome, no? Yeah, it seems awesome, right? It is actually awesome. So then what happened? Okay, next I have B. Again, like for this next, again, as soon as I place an H, I have to also update the frequency of H and say, now the frequency of H is 1. Now, the frequency of H is 1. What is the next? So you saw one thing. We have to keep track of the frequency of all the characters. So we will be needing or a hash map. We will need a hash map which will keep track, okay, frequency of a specific character A, how many times it has occurred, and I will keep on updating that. From this data structure, I have to grab out that specific character whose frequency is minimum. So again, we saw what's happening. You can use either a min heap or a multiset. That, bro, I'll grab out that character whose frequency is minimum. So I have to use any data structure which can give me the minimum value in the smallest possible time. For that, we have two valid candidates for us, priority queue and multiset. Usually you say set, but we can have same frequency also. So let's use multiset. Or you can also use set if you pair them up. So what we can do is, okay, I have to, and we know that, okay, for priority you have to write a big line in C++. Again, it's totally up to you. Whichever you want to use, you can use both priority queue and multiset, or you can also use set also. So we figure out, okay, what I'll do is I have to grab out the minimum frequency element. So I will make a multiset. In that multiset, again, I have to grab again, I can also make a set also, that will also work again, super fine. So in that, I have to grab out the element on the basis of its frequency. So this frequency, I will keep track, and then I can also track of the element itself, which is the character. So this will be the multiset which I will be making. First is frequency, because again, a set, if you grab out the first element, it will give you the smallest element, because a set is ordered in a increasing order. So it will give you a minimum value in the beginning, and for that you have to get the minimum frequency character. So you'll just use a multiset. Okay, now you have to use a multiset. So you'll simply ask your multiset, bro, multiset. Again, every deletion and insertion in multiset is O of login operation. So you will ask your multiset, and again, for you the size of this multiset is itself 26. So that's even not a much time for you. But let's see. Next, I will go and ask for this character. What I should place? I can see that, okay, roughly A, B, C, all of them are valid candidates. Oh, which means all of them has a frequency of minimum frequency. So ideally, when the frequency is minimum, you have to judge on the basis of lexicographic, like if its lexicography is small or not. So ultimately, and that's how your multiset set always also works, that if the frequency is same, then the things it will start ordering on the basis of next character, which is this next element for us, which is the character itself. So it will start ordering on the basis of your character. So now considering back, okay, A, B, C, E, F, and again all have frequency same. So the minimum frequency element, which I can again remember the fact, all of them in between all have frequency 1. Imagine that fact. So you will simply grab out the A itself. Okay, here I can place an A. Now when I place an A, I have to remove this from the multiset, increase the frequency in my map, then put it back to a multiset with the improve, or basically with the new frequency. Now, okay, next element comes is this question mark. Again, in the remaining places we don't do anything. Only in the question mark places we do something. That something is check the minimum frequency element, pull it out from multiset, increase its frequency, update the question mark, and push it back to multiset with increased frequency. Again, here I can see minimum frequency element is 1. Its character is B, so I'll grab out a B, increase the frequency of B, push it back to my multiset, and that's how it will actually become. Now I can keep on doing this, and ultimately you can also see that things look super fine. Are you sure things look super fine? Are you sure? Again, this is the answer. This is the answer. This is the answer, and that's gonna work. With one caveat, there's one thing missing in this. What's missing? Considering the exact same example that you had, again, we are just about to close it, that we had all the characters from A, B, D up till end Y. Now I gave you question marks, then I gave you C and B, and then I again gave you question marks. So with this fact, when you had all the characters from A to Z, again, if you saw in your multiset, you have all the characters from A to Z will have a frequency of 1, and the element C and B will have a frequency of 2. Now the first candidate which has a frequency of 0 will be a Z, so you will end up placing a Z here, right? Yes, correct. Then for this, next valid candidate will be okay. Now A has a frequency of 1, B has a frequency of 2, C has a frequency of 2, D has a frequency of 1, and so on and so forth up till Z, because Z have also pushed in here. So now the next valid candidate for me will be a A, so I'll put a A here simply. Okay, then I will see here again the frequency of A has become 2. Next valid candidate will be a D, so I place a D here. Then I placed, okay, next is E, so I'll place a E here. So ultimately, with above so far logic, you will simply return this string, which is A up till Y, then ZA, then CB, and then DE, and you might end up thinking it's the best answer, but I'll say no. Because did you forget one thing? One very basic thing which we told in the beginning. The ordering of these characters does not matter. Does not matter. But you have to return lexicographically smallest. So the ones which are at the question mark, we will have to shuffle them and put it in the lexicographically small. Again, we cannot change other characters location. We can only change the ones at the question mark. So we'll just grab those elements out, we will sort them up, and we will paste them. So I'll just grab this element out, Z, A, D, E. I'll sort them up, I'll get a A, D, E, Z, and I'll place them back, which means I'll get a A, D, Z, E. And that is the final answer which you have to return. And this is the thing which I was saying, that okay, this you will end up thinking only when you will submit the problem by yourself, and then you get a wrong answer. As we had seen in the chat also, people have like someone has mentioned about it, I forgot, but yeah, like unknown mentioned it, that exact same, you can see exact same error. This was the error which we are getting, and again this is the exact same error which you will get again if you solve it by yourself. So this was the final solution. Now let's see how things will go. So this is the answer. Again, this answer is the answer which you will end up building. If you remembered, I'll tell you the answer in this will be A, D, A, Z, A, D, E. So this will be your answer. But you remembered, the final answer will look like when you have a A, D, Z, E. So this is your, again, this will be your F answer. So I firstly make my answer and then I'll make my F answer. Again, you can improvise the code a little bit by just not using multiple iterations and stuff. But again, it's your choice. Firstly, I'll take the frequency. As I told you, I'll have to take the frequency, which means the frequency of a character is the frequency is this. I will get the multiset, which will keep track of the frequency of that specific character. That character's frequency will be here. Again, it should be in this order itself because frequencies needs to get the first priority and then the second order should be a character. Now, when this is done, firstly, I will have to keep track or have to get the frequency of all the characters existingly in my string S, because again, ordering does not matter for me. I just need to know the frequencies of all the elements, all the characters in my string S. I'll get the frequency. I'll just simply push all the characters in my multiset. Again, I'm pushing all the characters, even if its frequency is non-zero or not, still I'm pushing all of them in my multiset. Because if you remember, from my multiset, I have to grab out the minimum frequency element. So the element at least should be present. It should, even if my Z is not in my string S, but still I will push that in my multiset by saying, okay, character is Z with a frequency of 0. This I will push it so that I can actually grab it out from my multiset, right? Okay, now the main function comes in. I have n length because I have to go the entire length. Now I will be at that specific character I, right? If this is a question mark, then we need to think of something. If not, then simply push that in your answer. You cannot do anything. Now, if it's a question mark, then firstly, you have to place at that question mark, you have to place the minimum frequency character. So firstly, grab out the minimum frequency pair from your multiset, remove that from my multiset. Again, every operation is log in operation, right? Okay, no worries. Now increase the frequency of that specific character which you have grabbed out right now, because you will actually place it at the question mark itself. So you will increase the frequency of that specific character which you have grabbed out right now, and then push that character in your answer, because you have to build the answer, and then also push that pair in the multiset for the next future use. So this is what you will do if it's a question mark. Now, when this is done, which means your answer array is built, which means your answer string is built, which is this string, it is built. But you remember that these locations of Z's can be ordered just to bring out, because see, for these location at question mark, the ordering is not important. It's just the only thing important is it should be lexicographically smallest. So I'll just simply grab those elements out in the temp string. So I will have a temp string in which I'll grab all the characters which were at the question mark location. I'll grab all these characters. Now I will sort these characters in a decreasing order. Aryan, but you have to sort in the increasing order, right? Remember, see, I have to just say, ultimately in the end, my maqsad, my main aim is that I have to build this entire string in this order itself. So I grabbed one thing in my temp. I grabbed the elements Z, A, D, E. Then I sorted them in the decreasing order. So I sorted them in the order of Z, E, D, A. Aryan, why this? So that as I'm iterating on this entire string S back again, just to build the final answer, whenever I am at a question mark, I will grab out the last element from my temp and then remove it. Then again, last element from my temp, remove it. Last element from my temp, remove it. Last from my temp, remove it. And that's the reason I sorted in the decreasing order. You can also sort in the increasing order. Just make sure that you make sure that how you're actually putting the elements back. So I did the sorting in the decreasing order. Then I am just iterating on the entire string S. If it's a question mark, then I will grab from the end of my temp, and then remove from the temp also. If it's not a question mark, so whatsoever is there, put it as it is, don't touch it, and ultimately I can simply return the answer. With this, my time, I can simply say it's O of n log n, because I am doing a sorting in the very basic beginning itself. Again, I'm using a multiset, I'm using a sorting, all that stuff. Again, like here also I can see I did a sort of this. So I can simply say it's O of n log n. Again, you might end up saying, okay, Aryan, it's not exactly O of n log n, it might be something less, more, all that stuff. Again, this fact simply says I can sort the entire array whatsoever. What if all of them have question marks? So yeah, it's O of n log n. Space, because you are using this specific multiset. Now this multiset will have just 26 pairs. Okay, 26 space. Frequency also just 26. Okay, this answer might end up having a size n. So because this answer, again you can improvise that, but yeah, the bottleneck is O of n itself for the answer. And that's cool. Bye bye, take care, bye bye, goodbye.